this video, excuse me. In this video, we'll discuss an important discrete random variable, the binomial random variables, and show you how to compute probabilities for it. So, when is the binomial random variable relevant? Well, what will happen is you have repeated independent trials that are success or failure. Independent means the outcome of one trial doesn't affect the other. The outcome of each trial is a success or failure. We'll give you some examples in a minute. And there's the same chance of success on each trial. Okay, so we use the notation n is the number of trials, and p is the probability of success on each trial. So examples. Toss a coin 100 times. How many heads show up? Well, it can be anywhere between 0 and 100, right? But what we have here is binomial because each time there's a 50-50 chance. We have 100 trials. And we have probability 0.5 of success. Okay. Now, another example here, we have elevator rails we produce. And 3% are defective. We sample 100 elevator rails. What is the chance? Less than or equal to 2 are defective, because that might mean we pass the batch. Okay, in the airline business. Okay, well, I should say n here is 100 again. P is 0.03. Oh, we have to define the outcome. So we'll say a success is heads here. Failure, tails. Now, even though it's bad, we'll say a success is a defective elevator rail. A failure is an acceptable rail. And then we'll give you one more example here, and then we'll start computing some probabilities of interest. And the final example is airline sells 105 tickets. You know, they always overbook for a flight with 100 seats. What is chance? 95% of people show up. There's a 95% chance any given ticket holder shows up. What is the chance the flight is overbooked? Well, success is they show up. Failure, they do not show up. And we've got 105 trials. Each person can either show up or not, and we have a probability of 0.95 of success. Okay, so the two functions we've got that we can use to find binomial probabilities, see if I start typing here, Binom.DIST comes up. Okay, I'll use that instead of Binom.DIST. I'm not going to worry about binom inverse, but Binom.DIST, you can see you need the number of successes, trials, and then the probability of success. So you need the number of successes, you need the number of trials, the probability of success, And then you need basically a true or false. Let's suppose it's X successes. And then the true or false, if you use true, you get the probability of less than or equal to X successes. If you use false, you get the probability of exactly X successes. Okay. And then there's another function in Excel 2013 that makes things really a lot easier if you've got a Binom.DIST.RANGE. Okay. So you have the number of trials, the probability of success, and then a lower and upper limit. I think I've got this backwards. I think the probability comes first. So there'd be Binom.DIST.RANGE, I believe. And again, the syntax of that one, okay, you give me the number of trials, the probability of success, chance of success, and then you have S1 and S2. That's the chance of between S1 and S2 successes. Okay. Oh, I had that right, sorry. Apologize. So the number of successes, number of trials, and probability of success. I had that right the first time. I don't know why I thought it was wrong. Okay. So let's answer the questions we had here. So in other words, toss coin 100 times. Chance, let's say exactly 50 successes. Well, we'd use that Binom.DIST function. And so we want 50 successes. There's 100 trials. The chance of success is 0.5, and we'd use a false because we want exactly 50 successes, and that would be 8%. Okay. Chance of, let's say by success we mean a head. Chance of less than or equal to 40 heads. Well, that would be Binom.DIST. Okay. And so we'd say 40 successes or less, 100 trials, 0.5, and then we want the word true. So that would add up the chance of 0, 1 through 40 heads. Chance of greater than or equal to 60 heads. Now that's a little tricky if you don't have that Binom.DIST range. Okay, if you want the chance of at least 60 heads, that would be 60 through 100. And that's 1 minus the chance of 59 or less, because you take away 59, or Binom.DIST does only less than or equal to. So I'd have to do Binom.DIST. And we want 59 or less out of 100, 0.5 chance, and I need the word true there. But a much easier way to do that is if I have that Binom.DIST range in Excel 2013. So I say 100 trials, 50% chance of success, and the chance of between 60 and 100 successes. Same answer. Okay. Chance of between 40 and 60 heads. Well, you've got to take the chance of less than or equal to 60 minus the chance of less than or equal to 39. Now, because if you take less than or equal to 40, you'd be taking away the chance of 40 heads. So BINOM.DIST with a 60, okay, is 60 successes out of 100 with a true. That's a chance of less than or equal to 60. And now I look at the chance of less than or equal to 39. And that's going to be this. But again, if I use 96%, so it's almost sure that if you toss a coin 100 times, you'll get between 40 and 60 heads inclusive. But again, that Binom.DIST range, okay, I would say 100 trials, 0.5 chance of success in between 40 and 60. That's much easier. Same answer. Okay, let's talk about the elevator rails. Elevator rails. Okay, so we said 3% are defective. What's the chance? Less than or equal to 2 are defective. So I would do Binom.DIST less than or equal to 2 defective out of 100. And the chance of success is 0.03, and I'd use the word true. And so I get about a 42% chance less than or equal to 2 are defective. Now finally, the airline overbooking. Okay, chance flight overbooked. That means at least 101 show up. And that's 1 minus the probability of less than or equal to 100. Okay, so in other words, I could add up the chance of 0 through 100, take that away from 1 to get the chance of at least 101, or I could use that Binom.DIST range, which is easier. But if I do it this way, Binom.DIST, so I want 1 minus the chance of less than or equal to 100. So I want 100 out of 105, 95%. Again, I need that word true. And so I get a 39% chance the flight is overbooked. Or I could do Binom.DIST range, much easier. 105 people could show up, 95% chance they show up. The chance between 101 and 105 show up, 39%. So that's a lot of examples of the binomial random variable. In our next video, we'll talk about another discrete random variable of great importance, the Poisson random variable.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of 3 books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here, and you can sort of see 4.5, or his newest book, his analytics stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so, yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.